Hello. I'm trying to improvise more and more during the slides, so let's see how it goes. But today I would like to share some experiments I've been working with. And one thing that I've been working with is generating a summary or a description of a component, of a certain component in a code base. And here I think it's interesting to see how we can combine LLMs techniques with language engineering techniques, because I think that there are many people out there that basically have one skill that is the possibility to play with AI, and so they tend to use it to try to solve every problem, by brute force, if you want. You just throw it in this machine. You really hope that you get a result. And so, for example, with this approach, if I wanted to ask some LLM models to describe a piece of code, I will get some results. But first of all, I could only throw at it entire files, right? Because I will miss the ability to identify single elements within this file. So this is a first small contribution that we can get from language engineering. I can parse a file, I can recognize certain elements, for example, methods, and I can get the code just of these methods. Instead of, I don't know, splitting a large file randomly, I can organize it in blocks that make sense, that represent elements with a semantic significance. Okay, so I can take, for example, the code of a method and I can throw to the LLM and I will get some result. Good. And the less I know about that code base, the more convincing this description will look like. So this is great when you don't know anything about the code base, because you would like to understand something, you get an explanation, you cannot really deny that is correct because you don't have an opinion yourself, so you trust it and you feel like the problem has been solved. That's a great feeling. Okay, but I tried this morning to apply this problem I was working with a particular legacy code base, and I use it with a piece of code that was basically representing, let's say, the configuration of a service. In this code, written with a special language to define just this kind of bindings, this code that was just, I don't know, maybe 20 lines long, we included some services, we configured them in a certain way and we included some modules and we organized it to expose a certain service. Great. So if I give this piece of code to an LLM, it will tell me, oh, you are importing module A and module B, and you are configure them in this way to provide a service. Great. But what does this service does? What is useful for? Well, the LLM, if you are lucky, will not answer that because it cannot know from the code that you are giving to it. If you are not lucky, it will just come up with an answer that is not necessarily related with reality. Okay, so you need in some way to provide context. And maybe your first attempt could be setting up a RAG system. So you process your code base, segmenting it, perhaps using some language engineering techniques, so dividing the code in functions, methods, classes, and so on, and using the resulting document to create a RAG system. If you do that, the problem is that when you provide this configuration service to the RAG system, it will find related information, but related information will be other configuration services. It will not be the definition of the modules that we are importing. That instead will be very useful, because if you say we are importing module A and module B, and module A does this and module B does that, then it's easier to figure out what my service is providing. The problem is that to identify what module A and module B means in this case, you will need to parse the code, resolve symbols, find the definition of these symbols, and then use those to provide context to the LLM. In this way, you will get a more meaningful answer. But that, for doing that, you cannot just take some text and throw it at the LLM. You need to be able to implement parsing and symbol resolution, which is not trivial. But I think it's fascinating how we can get some result with AI with non-language engineering skills. If you want to get good results, you can leverage language engineering skills and getting a much more meaningful result. And from the point of view of a language engineer, this is very interesting because the LLM help solve problems that we couldn't easily otherwise. Like, for example, generating a paragraph describing what a piece of code is doing. This is something that is much easier to solve with an LLM, provided you build the right context. And for that, I think language engineering skills are very useful. So yeah, just sharing some reflection on these experiments, and I would be very happy to hear your thoughts, hear your feedback, hear about your experiments, and ideas about other things we can discuss or other things I can experiment and then share back. Thank you and have a great day. Bye.